Today, the topic of discussion is on basic concept of strength of material, that is Module 1, Part 9, PCME 403. Myself, Dr. Suman Das, HOD, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. Now, in this video, I will discuss principal stresses and Mohr cycle, principal planes and Mohr cycles and their graphical representation. So, the construction of Mohr cycle for complex state of stress, that is sigma x, sigma y and tau xy, these three are present. Where sigma x, sigma y and tau xy, these three are known. So step number 1. So label the element ABCD and draw all stresses. So this is the ABCD. If you see the diagram, A, B, C, D, and this is sigma x, sigma x, sigma y, sigma y. So this sigma x and sigma y, these both are tensile, that is positive. And this is tau xy, this is tau xy, and this is tau xy, and this is tau xy. So tau xy and sigma x and sigma y, these three are shown in this diagram. Now step number 2, setup axis for the direct stresses as abscissa. That means this is the abscissa, that is the direct stress sigma in x-axis, and shear stress as ordinate. So this is the shear stress, that is the tau as ordinate, that means in the y-axis. So first we just plot sigma and tau, sigma in the x-axis and tau is in the y-axis. So sigma and tau, these two are mutually perpendicular. So if you see the diagram, this is sigma and tau, this is mutually perpendicular. Step number 3, so using sign convention and some suitable scale, plot the stresses on two adjacent faces, that is AB and BC. So this is AB and BC on the graph. Let OL and OM equal to sigma x and sigma y. So this is OL, that is plot sigma x, and OM, this is OM, that is sigma y. So both are positive. So we plot that sigma x and sigma y in the positive direction of sigma. So sigma x and sigma y respectively on the O sigma axis. Draw LM perpendicular to O sigma. So draw LM. So this is L and this is M. So draw LS. Sorry, draw LS perpendicular to O sigma. Draw LS perpendicular to O sigma. Draw LS perpendicular to O sigma axis and equal to tau xy. So this is value is equal to tau xy. This is tau xy, L to S, and LS equals to tau xy. Here LS is drawn, LS is downward as tau xy on AB faces negative. So why LS is downward? Because in the AB faces, so if you see that element, so in that element, that is in the downward direction, that's why negative. And draw MT. MT means this is M and this is T. MT perpendicular to O sigma axis and equal to tau xy, and MT equals to positive tau xy. Here MT is upward and tau xy BC phase is positive. So in the BC phase, in the element, that is positive. That's why it is in the upward direction. Now step number 4, join S to T. So if we just got that 2 points S and T, and we just draw the S and T point, join S and T, and it will cut O sigma axis at point C. So it will cut the O sigma axis at point C, and with C as center and CS or CT as radius, C as a center and taking CT or CS as radius, so draw a circle. So we have to draw a circle, and this circle is called the Mohr circle. So that is step number 4. Now step number 5, draw at the center, draw a line CP. So at the center, draw a line C to P. Draw a line C to P. at an angle 2 theta in the same direction as the normal to the plane makes with the direction sigma x. So this is the angle theta. So we have to double already in my previous video we have said that I have discussed that the theta angle should be doubled. So that is theta. So that theta should be doubled. That means 2 theta. So at an angle 2 theta at the same direction as the normal to the plane makes with the direction of sigma x, makes with the direction of sigma x. So this is also theta. So you have to just double it. So that should be 2 theta. Next, step number 6. So calculation, that is the draw a perpendicular PQ and PR where the PQ equals to tau and PR equals to sigma n. So the center is should be OC equals to sigma x plus sigma y by 2, and radius is nothing but the from the diagram root over of CL square plus LC square LS square. So we just put the value where we are getting this. So we are getting also the sigma n and also getting the value of tau. So this is the step number 6. Now finally we just plot this. So this is the CP and this is the value of tau and this is the value of sigma n. Okay, so PR is the sigma n and PQ is the value of tau, and this is the circle that will touch the sigma axis in the 2 points. So one is the sigma 1 and another should be sigma 2. So one is the principal stress and another, there are two principal stresses. One is the maximum and another is the minimum. So from this, so this is the entire Mohr cycle. So this represent the state of stress. So P is the state of stress of that Mohr cycle. So Mohr cycle for some special cases. Number 1, motorcycle for axial loading. So this is the member. So this member is subjected to axial loading. So in that case, only the in the x direction there is no forces in the y direction. So there is no question of stress in the y direction. So only the stress present in the x direction. So sigma is nothing but p by a. So sigma x equals to here the tau xy, sigma y equals to tau xy equals to 0. So there will be no sigma y. So if we plot that, so this should be the diagram. So only sigma x is present. Similarly, motorcycle for the torsional loading. So here only the torsion or twist is present. So that is the tau. So here tau xy is nothing but this value. So sigma x equals to sigma y equals to 0. So we plot this. So that should be the tau max. So the diagram of the motorcycle should be like this. So in the case of pure shear, that means a member is subjected to only the torque. We are only the pure shear. There is no direct stresses, no sigma present. So this is the motorcycle. So sigma x is nothing but minus sigma y, and tau max is the plus minus sigma x. So this is the diagram of motorcycle. So here the shaft compressed all round by a half. So this is the shaft compressed from all the direction. So this is the diagram of motorcycle. A thin spherical shell under internal pressure. So only the sigma in the all direction. So here sigma 1 equals to sigma 2 equals to PR by 2t, and that is PD by 40. That is in the terms of tensile. So this is called the hoop stress. So in the case, the diagram should be like this. Is only on the point. So here the cylinder under pressure, if you see the diagram, the thin cylinder is under pressure. In that case, sigma 1 is Pdy 2T, we know that is they call the hoop stress, and sigma 2, that is the sigma 2, that is sigma 2, this is sigma 2, that is Pdy 40. So that is the uh, longitudinal stress. So longitudinal stress is half than the hoop stress, that is circumferential stress, and this is the uh, representation of that two stresses, sigma 1 and sigma 2. So this is sigma 1 dot, that is pdy pr by t or pdy 2t, and this is pr by 2t or pty 40. So this is value is sigma 1. So this is sigma 2 and this is sigma 1. Sigma 1 is 2 times greater than the sigma 2. Now the bending moment applied at the free end of the cantilever. So that is bending moment applied at the free end. So sigma 1 is nothing but my by I, and sigma 2 equals to tau xy equals to 0. Only the bending stress is there. So that is the motorcycle diagram of motorcycle. Now this is a simple problem. So the motorcycle for a plane stays in a circle of radius r with its origin 2r on sigma axis. The sketch of the motorcycle and the determine the sigma tau max, tau mean, tau sigma max, sigma mean, and sigma average, and tau xi max for the situation. So we have to calculate the value of sigma x, sigma max, sigma mean, and tau average. So sigma max equals nothing but 3r, sigma mean equals to r. So sigma average is the sum of these two divided by 2, sum that is to 2r, and tau max is nothing but sigma max minus sigma mean by 2. So finally you are representing that this the stresses sigma max, sigma mean, and tau average. So this is the 3r, this is the r, and this is the 2r. Now the another one, that is the direct tensile stress, that is 120 MPa and 70 MPa act on a body on mutually perpendicular planes. So this is the figure. This is the element 120 and this is the 70. These two are the direct perpendicular planes. What is the magnitude of shearing stress that can be applied so that the major principal stresses at the point does not exceed, that is 130 MPa. So determine its value of minor principal stresses and maximum shear stress. That means sigma 1 and sigma 2 you have to calculate. So directly from the formula, that is the sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau square. So we just put the formula and we just put the value of that, and that is the major principal stress. So we are getting this uh, value of sigma 1. This is the value. So the minor principal stress, so that you just put the value of sigma x, sigma y, and tau, and we are getting the value of minor principal stress, that is 55 MPa. And finally tau max is nothing but sigma x minus sigma y by sigma 1 minus sigma y by 2. So putting the value of sigma 1 and sigma 2, and we are getting the value of, that is minor principal, that is the tau max. Thank you very much.